Alright guys, this is video number 3 of the repair on these floodlights that were used for bow fishing. And okay, so I've got the, as you can see, I've got the paint sanded off, and I'm down to the bare metal there. So that right there, just doing that, is going to help extend the life of your LEDs. So yes, by having some paint in between the chip and the heatsink, you're going to have your cobs running. They will be running at a higher temp than if you sand them down. You'll drop a few degrees by sanding down to the bare metal, having a better interface there. So that naturally will extend the life. Running them as cool as you can, that will extend the life. These things are rated at 50,000 hours. Well, that's in perfect environment. So people see that number and they think, oh, they're going to be good for 50,000 hours. They ain't going to have to replace these things for 30 some years or whatever. Well, that's in a perfect world. This is far from a perfect world, guys. As you can see, I'm replacing them. I don't know how old these are, but I got people, bringing these things to me. There's chips that are burning out, and they're happening for different reasons. I understand. Sometimes they get water in there, and you got corrosion going on. That's obviously not going to be good for the electronics and stuff in there. So yeah, but anyway, that's one problem with these Chinese fixtures. They're cheap. They're really appealing in that regard. But, guys are spending a decent amount of time mounting these things up. And they're even designing light boxes around them. And, they burn out eventually. A lot of them do. Not all of them, but some do. And, okay, so talk about the chips themselves a little. Okay, so this here is a 50-watt cob. This is the one that burned out, that came out of there. It's probably around 2700 Kelvin temperature color wise. And I'm putting 3000 Kelvin halogen spectrum in there. And what you want is some high quality ones. When you're going to do all the work, the last thing you want to do is put another crappy cob in there. So these appear to have copper core PCBs, and that's basically, it's nickel plated. So if I scratch this, let me see here. I'll scratch it deep. And if you look, you can kind of see the copper color in there. So that's good. They are copper core. Aluminum is not as efficient as transferring heat away from the chips. So copper is preferred, so that's good. That doesn't mean the chips are good. So the chips, you can see them in there. They're probably 24 mil. And that's basically a dimension of the actual chip itself, the actual LED, each LED in the arrays. So what I try to get are 45 mil chips. They're bigger chips than the ones that are on these PCBs, and they can handle a lot more power. So instead of maybe being able to handle 1 or 2 watts, a 45 could handle like 3 watts. So they're much more robust in that regard. Here's another tip here I was going to say in the last video. I'm trying to get the new cobs out that I'm replacing with here. A lot of people don't realize this, but you can actually put a 100 watt cob in a 50 watt on a 50 watt driver. So this is a 100 watt fixture here, but you got two 50 watt drivers pushing two 50 watt chips. So what you can do is you can actually put a 100 watt chip or cob in place of it, and you'll have double the arrays. And what that means is each array will be seeing less amps, and it will be running much more efficient. So you can gain probably 15 to 20% more light output with not using any more power by stepping up to a 100 watt chip. And also, if you look at this chip, it's going to be kind of hard to see because they're so big. This chip actually has 45 mil. This cob actually has 45 mil chips in it. This one can't really see for some reason. Here, let me pull this one out. This one here you can see a little better. No, not really. But the chips themselves in there are much bigger. And you can see there's multiple leads going down to each array. So these chips, they're also copper core. They're still Chinese. You know, they're not the best, but about in this world, this is about as good as it gets. These 45 mil on a copper core PCB is about as good as it gets. They're gonna blow these others away. So there's way more chips going on in here. There's double the chips. There's 100 in there, and there's 50 in here. And each chip, like I said, is bigger. So you're gonna gain light output just by changing over to these. But they are more expensive. You know, you're gonna pay double the money. But again, these things, you know, you can find them on eBay. There's people charging a bunch of money for these things. I understand getting them to the US and then selling them here, you're going to have to get a markup there. But you can personally buy them directly from China if you want to. And, you know, 50 watters are only like $5 each, you know. And you can get 45 mil versions of the 50 watters too. And they're going to be much more durable than some of these ones here with the tiny little chips. They're going to last a lot longer. And if you do this preparation here and you use some really good thermal paste, you're going to really give them the best shot they got. I do understand that some of these heat sinks are undersized and they get hot. Everything gets hot, and that just shortens the lifespan of everything. So basically what I'm going to be doing here now is applying thermal paste and mounting the chips, and I'm going to be soldering these wires on there. So you want to make sure you've got the orientation correct. So it's kind of goofy the way they have these things marked, but you'll see a plus sign on the left there and then a negative sign on the right. So that's your positive and negative, but your leads are on the opposite, you know, axis. So you want to check so that you see they're staggered. So your negative sign is on the right, while you're on the lead on the right is your negative, and your positive is on the left. So the lead towards the left is your positive or anode. So that's how I memorize it. And obviously some of these wires are a little longer than others. Like your positive lead is longer than or shorter than the negative lead. So you're going to orient your chip. It's just a square bolt hole pattern. So you can mount it any which way you want. Just mount it so that obviously the leads will line up best for you. So that's what's next. I'm going to apply thermal compound, and then there's the retainer bracket here that goes over the top, and that just screws down. You solder them first. After they're soldered, then I clean the glass, do assembly. So basically, you got a gasket here. And we'll go into that in the next video. All right, so I'm going to get back to you guys once I've got these soldered up. All right, take care.